metallographic sample preparation, and microscopic observation of brazed joint of stainless steel. Brazing is a metal joining method in which the base metal does not melt. The core principle is to use solder metal with a melting point lower than the base metal as the filler material, heating to a range above the melting point of the solder but below the melting temperature of the base metal. Wet the surface of the base metal with liquid solder metal, filling joint gaps by capillary action, and diffuses with the base metal. Eventually form a permanent connection of metallurgical bonding. A wide range of lead welding processes can be used to weld metal and non-metallic materials, but its limitations are equally clear. It mainly bears shear force and is not suitable for high-stress situations of tension and bending. The operating temperature should not exceed the melting point of the solder metal. Next, we will share the metallographic preparation of lead solder samples. Cutting. We cut and sample. Use metallographic cutting machine with a 60 grinding wheel cutting blade. Accurate sampling of welding parts of stainless steel lead welded specimens. Adequate cooling is required during cutting. Avoid enlargement of the heat-affected zone or organizational changes. Make sure that the samples taken can truly reflect the original state of the joint. Mounting. After cutting, the surface of the sample is cleaned to remove oil and debris. Put it in a transparent silicone mold. Injection of UV curable adhesive. The mold is then irradiated in a photocurator for 1 minute. Fast curing of resin. Light curing cold mosaic avoids hot pressing mosaic. Effect of possible thermal stress on lead welded joints. At the same time, the operation is convenient and efficient. Grinding and polishing. Preparation of mirror surface by standard 4-step method. Step 1. P400. Silicon carbide sandpaper quickly flattens the surface of the sample to eliminate cutting damage. This is the scratched state left by 400 eyes. Step 2. Pause grinding and polishing plate plus 9-micron polycrystalline diamond polishing liquid. Remove coarse abrasion marks and initially reduce the deformation layer. This is the scratch state left by 9 microns. Step 3. SC polishing Buddha. 3-micron polycrystalline diamond polishing solution. Refine the surface to further eliminate scratches. This is the scratch state left by 3 microns. Step 4. ZN polishing Buddha 50 nm silica polishing solution. The final fine polishing removes fine scratches and obtains a scratch-free mirror surface. This is the scratched state left by 50 nm. Observation. The prepared sample is observed under a metallographic microscope. Focus on the joint clearance. Usually 10 to 100 microns is appropriate. The gap is too small for lead to flow in. If it is too large, the lead material will not be filled, and it is easy to get holes. Strength directly discounted. The diffusion layer between the solder metal and the base metal can also be seen under the microscope. This is evidence of metallurgical bonding. If there are unmelted pores and slag inclusions, it means that the process parameters are not well controlled. So metallographic analysis is not just about looking. He is the final judge of brazing quality. By observing the microscopic mass of the joint, it optimizes solder metal, temperature, clearance, to make each connector firm and reliable. Suitable materials plus precise process plus standardized sample preparation equals high-quality brazed joints.
Trojan. Discover the truth of material.